Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. And today we're going to learn about factoring trinomials, and we're going to factor each completely. So if I was given this trinomial, b squared plus 8b plus 7. Okay. Notice again our a value is equal to 1. So we had to ask ourselves this question. We had the b value and the c value, b value being 8, c value being 7. What two numbers multiply to be 7 but add to be 8? Okay? So we ask ourselves this question. What two numbers multiply to be a 7 but add to be an 8? And the two numbers I see for that are 7 and 1, right? 7 times 1 is 7 times 1 is 7, and 7 plus 1 is 8. So we can break this down then to be b here, like this. And we said, well, it's a positive 7 and a positive 1. And there we go. We have factored this completely. Our b squared plus 8b plus 7 can factor out to be b plus 7 times b plus 1. N squared minus 11n plus 10. Okay. Now, we have an a value of 1, right? The coefficient in front of the n squared. And so we're going to ask ourselves this. What two numbers multiply to be our c value, that 10, but add to be a negative 11? So what two numbers multiply to be 10 and add to be a negative 11? Okay. Well, if you think about it, our two numbers, well, what about a negative 10 times a negative 1, right? Negative 10 times a negative 1 is a positive 10, but negative 10 plus a negative 1 is a negative 11. Okay? So we can break this down to be two parentheses here, like this. Okay? And let's take the first one, n minus the 10, and then n minus the 1. So we take the two numbers that we found right here. Okay? Two numbers we found. We're going to put them in there and break them apart here as two different n values. And you can also see if we multiply this set back out distributed, we would get what's up above, right? The n squared minus 11 plus 10. So again, our final answer here is n minus 10 times n minus 1. M squared plus m minus 90. Okay. Well, we have it on our ax squared plus bx plus c form, and our a value is equal to 1. So let's ask yourself the question. What two numbers multiply to be my c value, which is my negative 90, but add to be my b value, which is a 1? So what two numbers multiply to be negative 90, but add to be a positive 1? Okay? Well, if we take negative 9 and a positive 10, so negative 9 and a positive 10, well, negative 9 times 10 is a negative 90. But when I add them together, I get a positive 1. So those are two numbers that can do that. Multiply to be negative 90, add to be positive 1. So now we're going to break this quadratic, put it into factored form. So we have m there and an m here. And then we're going to take our two numbers and put them in the empty spaces. We minus 9, and we add a 10. And there we go. Our final answer here is just n minus 9 times n plus 10. N squared plus 4n minus 12. Okay. Well, what I want to do here is I want to look at this and say, okay, since our a value is equal to 1, I'm going to ask what two numbers multiply to be my c, negative 12, but also add to be my b value, which is 4. Okay, so what two numbers multiply to be negative 12 and add to be 4? Well, the way I see it, okay, the way I see it here is a minus 2 and a positive 6. Negative 2 times 6 is a negative 12, but when I add them together, I get a positive 4. Okay, so because negative 2 plus 6 is 4, right? So when I break this down, I have my factoring here, break it down into parentheses, and in the beginning of each one, I'm going to take those two numbers that I found and write n minus 2. N plus 6 right there, and there we have it. Our final answer here is just n minus 2 times n plus 6. N squared minus 10n plus 9. Well, since our a value here is 1, I can ask myself a question. What two numbers multiply to be a 9 but add to be a negative 10? Okay. Well, what two numbers multiply to be 9 but add to be a negative 10? The way I see it is a negative 1 and negative 9. Negative 1 times negative 9 is a positive 9, but when I add them together, negative 1 plus a negative 9, I get a negative 10. Okay, so those are my key two numbers. So when I write this out, I have n, kind of broke it down in two parentheses here, n minus 1, my first number, and then times n minus 9, and there we go. We've factored out our trinomial to get our final answer here of n minus 1 times n minus 9. B squared plus 16b plus 64. All right. Well, since our a value is just 1, I can ask myself the question, what two numbers multiply to be my c value, which is 64, but add to be my b value, which is 16? And that's our b value, that's 16, not the variable b. Okay? So looking at that, when I think about it, I said, okay, well, what about 8 and 8? 8 and 8, right? 8 times 8 is 64, but 8 plus 8 is 16. So when I write this out, I can factor this out, right? I have b, it's normally like this, b and then the b, right? And we say, okay, our two numbers, 8 and 8, b plus 8 and times b plus 8. But I can write this even in a more simpler form, that's the word I'm looking for, right? Because I have the same thing written twice, b plus 8 times b plus 8. So I would write this as b plus 8 squared, right? The same thing times itself, same thing multiplied by itself is that thing squared. So our final answer here is just b plus 8 all squared. M squared plus 2m minus 24. Okay, so m squared plus 2m minus 24. Well, what I'm going to ask myself here is what two numbers here multiply to be my c, which is negative 24, but add to be my 2. Okay, so what two numbers multiply, add to be 2, my b value, what two numbers add to be 2, b value, multiply to be negative 24, my c value. Okay, and what I'm thinking about here is a positive 6 and a negative 4. Okay, 6 times negative 4 is a negative 24, but 6 plus 4 is a positive 2. So I'm going to break this out in factored form here. Okay, my two parentheses, my m values here, my variables. I have m plus 6 and then m minus 4. And there we go. Our final answer here, taking those two numbers, put them in each parenthesis. And it really doesn't matter the order. If it was m minus 4 or m and m plus 6, that's fine. But our final answer here is just m plus 6 times m minus 4. X squared minus 4x plus 24. Okay? Since our a value is 1, okay, what I'm going to ask myself here is what two numbers multiply to be 24 and add to be a negative 4. Okay? Well, at first when I'm thinking about this, I'm trying some things out. I'm having a difficult time finding two numbers there. So what I'm going to do is just break down. So a lot of times when I have a hard time finding two numbers, let's go break it down. Let's put it right here. 24. I'm going to take what's being multiplied and say, okay, let's make a list of all the numbers together that multiply to 24. Well, two numbers, 1 and 24, 2 and 12 going there, right? 3 and 8, 4 and 6, right? And then after that, it's just going to flip back, right? 6 and 4, 8 and 3, 12 and 2, and 24 and 1, if I kind of follow that. But here are all the pairs of numbers that multiply to be a positive 24, right? And then they both could be negative, right? It could be negative 4, negative 6, negative 3, negative 8, negative 2, negative 12. And we could write all those, but it doesn't matter. But sure, let's do that. Negative 1, negative 24, technically, negative 2, negative 12, negative 3, negative 8, and negative 4, negative 6. Okay. So now I want to go through and say, okay, what two of these numbers can add to be a negative 4? Well, it can't be any of the positive ones, right? The positive ones, right? You can't actually positive numbers get a negative number. So negative 1 plus negative 24, no, that's negative 25. Can't do that. Negative 2 plus a negative 12 is a negative 14. I don't think so. Negative 3 plus a negative 8 is a negative 11. Nope. And negative 4 plus a negative 6 is a negative 10. So none of all the numbers that can multiply could possibly multiply to be a positive 24 added to be a negative 4. And so with that being said, this problem is not factorable. not factorable. Okay, that's our answer. There's no way we can actually factor this. We've exhausted all the possibilities. K squared minus 13k plus 40. Our a value is 1, so now I'm going to ask myself the question, what two numbers multiply to be a positive 40, but add to be a negative 13? Okay, so what two numbers multiply to be a positive 40 and add to be negative 13? And I'm thinking about, well, it's a positive number multiplied, add to be negative, so they're both going to be negative, okay? And a negative 8 and a negative 5. Negative 8 times negative 5 is a positive 40, but negative 8 plus a negative 5 is the negative 13. So, since we have those two numbers, we can factor this out here to our two parentheses, putting k first in each one. And we just write the two numbers, k minus 8 and k minus 5. And there we go. Our final answer here, and again, it really doesn't matter. It could be k minus 5 times k minus 8. But anyway, our final answer here is k minus 8 times k minus 5. A squared plus 11a plus 18. Okay, so a squared plus 11a plus 18. I'm going to ask myself the question, what two numbers multiply to be 18, my c value, but add to be my v value, which is 11? So when I think about the two numbers multiply to be 18 and add to be not 11, I said it right there, I'm thinking 9 and 2. 9 and 2, right? 9 times 2 is 18, and 9 plus 2 is 11. Okay? So when I break this down into my factored form, I write my a's first, my parentheses, and then I just kind of fill in the two numbers we have. A plus 9 here, a plus 2, and there we go. Our final answer being a plus 9 times a times 2. Now again, it doesn't matter the order. It could be a plus 2 times a plus 9. N squared minus n minus 56. Okay. Well, what I'm going to ask myself here is what two numbers multiply to be a negative 56, my c value, but add to be my b value, which is a negative 1. Okay. Well, two numbers multiply to 56, negative 56, add to be negative 1. Well, I know 8 times 7 is 56. Okay. So if I'm going to have two of them that are multiplied to be negative 56, but add to be negative 1, I'm going to make the 8 negative and the 7 positive, right? So negative 8 times 7 does give me my negative 56, but when I add the two together, I get a negative 1. So we can write this out here, okay, our n value first, n minus 8, right there, times n plus 7, and there we go. Our final answer in factored form is n minus 8 times n plus 7. N squared minus 5n plus 6. Okay, so I have n squared minus 5n plus 6. So what I'm going to do is ask myself the question, because our a value is 1. What multiplies to be my c value, a 6, but adds to be my b value, which is a negative 5. So what two numbers, okay, multiply to be 6, but add to be negative 5? Well, I'm thinking 2 and 3, right? And both being actually negative. Negative 2 and negative 3. The reason why I'm doing that is negative 2 times negative 3 is my positive 6. But negative 2 plus a negative 3 is my negative 5. So I write this in factored form. I have my two parentheses like this. And then say, okay, put our two numbers here that we found, n minus 2, n minus 3, and there we go. Our final answer here is just n minus 2 times n minus 3. B squared minus 6b plus 8. All right, so our variables b here, and we have an a value, that's 1. That's the number or the coefficient right in front of our variable squared. Okay, so since we have that, we have to ask ourselves this question. What multiplies to be my c value, which is 8, but adds to be this b value, a negative 6? What two numbers multiply to be a positive 8, but add to be negative 6? And the ones I'm thinking of are a negative 2 and a negative 4. Negative 2 times negative 4 is a positive 8, but a negative 2 plus a negative 4 is a negative 6. So we can break this apart into two parentheses when we factor. Okay, we're going to b at the beginning of each one. Then we're going to take both these numbers and just minus 2 and minus 4. And there we go. Our final answer here is just b minus 2 times b minus 4. N squared plus 6n plus 8. Well, if I was going to n squared plus 6n plus 8, I notice my a value, the coefficient right in front of our n squared, is just 1. So I can ask this question. What multiplies to be an 8 but adds to be a 6? Okay, what multiplies by 8 but adds to be a 6? What two numbers we're looking for? Two numbers I am thinking about are 2 and 4. 2 times 4 is 8, and 2 plus 4 is 6. Okay, so now I can break this apart in two parentheses. So, okay, we have n here at the beginning of each one, and then we put our two numbers in each the other sides of each parenthesis. So we have a plus 2 here, and a plus 4. And there we go. Fairly simple to factor these easy ones here with an a value of 1. Our final answer here is just n plus 2 times n plus 4. 2n squared plus 6n minus 108. Well, what I notice here is I like it. It's easier to factor when our a value is 1, the coefficient from our n squared here. But we don't have that. But I notice I have a 2, a 6, and a 108. Each one of these are even. So I can pull out a 2 from all parts. So pull out a 2 from there, 2n squared, I get a n squared. 6n becomes a 3n. And 108 basically divided by 2 is a 54. 54 there. Okay? So now what I can do is I can imagine a 2 just on the outside, and I can now ask the question, what two numbers multiply to be a negative 54, that's c value here, and add to be our b value, which is 3. What two numbers? Well, 54, I'm thinking 6 and 9, and one's going to be negative, one we want a positive 3. So if we have a positive 9 and a negative 6, 9 times negative 6 is a negative 54, but 9 plus a negative 6 is a positive 3. So when we break this apart, the 2 still stays outside, and we have our two parentheses here. Okay, we're going to have n at the beginning of each one, and then we're going to have the numbers we found here, n plus 9, like that, n minus 6. And there we go. Our final answer is 2 times n plus 9 times n minus 6. 5n squared plus 10n plus 20. All right. Well, I really like it easier. It's easier when our a value is 1. So I'm going to see if I can pull out this 5 from all parts. Well, 10 and 20 both are divisible by 5. Divisible by 5. So I can pull out a 5 here. Then I'm left with just an n squared there, plus 5 goes into 10 2 times, so we have 2n right there, and 5 goes into 24 times. Okay, so now we have 5 times n squared plus 2n plus 4. So we have to ask ourselves the question now, what multiplies to be a 4, but adds to be a 2? This was a little tricky. Let's go make a table. Let's make a table of all the numbers that are multiplied to equal 4, all the two numbers here. Well, 1 and 4 equal 4. 2 and 2 equal 4. Okay. Then I can flip those. You're going to say 4 and 1. What about negative? Right? Negative 1 and negative 4, and negative 2 and negative 2, right? They both multiply. All these multiply to be a 4. So those are all the combinations that two numbers that multiply to be a 4. So let's go see if they can add to be a 2. 1 plus 4 is 5, so no. 2 plus 2 is 4, nope. Negative 1 plus negative 4 is negative 5, nope. Negative 2 plus negative 2 is a negative 4. So we have no options, right? All the combinations that multiply to be a 4, none of them add to be a 2. And so that's it. We have factored this out completely as it is, okay? And we kind of don't necessarily it's not factorable or not, because we pulled out a 5 from it, but really we're left with just 5 times n squared plus 2n plus 4 as our final answer. 2k squared plus 22k plus 60. Okay. Well, what I want to do, I want to see if I can get an a value of 1. I know all of them are divisible by 2, so I can pull out a 2 from all parts here. So I'm left with just a k squared out front because 2 divided by 2 is 1, plus 22 divided by 1 is 11, so we have 11k right there, and 2 goes into 60 30 times. Right? So I pulled out a 2 now, and we have an a value of 1. So now I can ask myself the question, what two numbers multiply to be a 30, but add to be an 11? This was tricky. Okay, what two numbers multiply to be 30 but add to be 11? Now, if you're struggling with this, what we can do is just kind of break down what are the factor or multiples of 30. What two numbers? 1 and 30, 2 and 15, 4 goes into 33 and 10. Sorry, 3 and 10. 4 does not go into 30. 5 and 6. And then at that point, we flip back 6 and 5, 10, 30, 15, 2, and 30 and 1. Any of these two numbers add to be 11. This one's easy to see as the 5 and 6. So my 5 and 6 here are the two numbers that add to be 11. Okay. This 5 has a little weird hairdo. All right, but 5 and 6 add to be 11. So when we factor this out, we have our k into two parentheses, right? We have a positive 5 and a positive 6, and there we go. We have our final answer of 2 times k plus 5 times k plus 6. A squared minus a minus 90. So if I was given a squared minus a minus 90, all right, well, what I want to ask myself is, I have an a value that's coefficient in front of a squared is 1. What two numbers multiply to be negative 90, but add to be negative 1? Okay, add to be negative 1. There we go. Well, this one's a little tricky. So 90, I've popped my head, I think two numbers that are easy to multiply to be 90. That's 9 and 10, right? 9 times 10 is 90, but we're negative 90, so one of them has to be negative. But those two numbers are 1 apart. So a negative 10 plus a positive 9 is a negative 1. A negative 10 times a positive 9 is a negative 90. So my two numbers here, negative 10 and positive 9, together multiply to be negative 90, but when I add them, I get negative 1. So when I factor this out, I have my two parentheses here. Okay? A values in the beginning of each one, and then we just have a minus 10 and a plus 9. And again, doesn't really matter the order. It can be a plus 9 times a minus 10. Either way, our final answer here is just a minus 10 times a plus 9. P squared plus 11p plus 10. All right. Well, I have an a value of a 1 here, so I'm going to ask myself this question. What two numbers multiply to be 10, but add to be 11? What two numbers multiply to be 10, but add to be 11? This one's kind of tricky, right? I'm thinking of a 10 and a 1. 10 and a 1, right? 10 times 1 is 10, but 10 plus 1 is 11. So we have that there. This was a little tricky, but as we have it, we can break this down into two parentheses. P, the beginning of each one. Better P there, okay? And then we have a plus 10 and a plus 1. And there we go. Our final answer here is just our factor form of P plus 10 times P plus 1. 5v squared minus 30v plus 40. So 5v squared minus 30v plus 40. Well, I see a 5 is in all parts. Since a 5 is in all parts there, I can pull out, right, a 5 from all parts. And my meaning that is 5 goes into 30 and 5 goes into 40. So if I pull out a 5 there, I'm left with a v squared right there, minus 30 divided by 5 is 6v, plus 5 goes into 40 8 times. So now we have 5 times v squared minus 6v plus 8, which is great, because now I have an a value of 1. So now I can ask myself the question, what multiplies to be an 8, but adds to be a negative 6? What two numbers? The two numbers I'm thinking about that multiply to be an 8, but add to be a negative 6 is a negative 2 and a negative 4, right? Negative 2 times negative 4 is a positive 8, but negative 2 plus a negative 4 is a negative 6. So when I write this out here, I make sure I bring down the 5. I have my v, my two parentheses here, okay? And we just have our two numbers there, a minus 2 and a minus 4. And there we have it, our final factor form of 5 times v minus 2 times v minus 4. 2p squared plus 2p minus 4. So 2p squared plus 2p minus 4. Well, I like it better when a value is 1, the coefficient in front of p squared. But I notice there's a 2 there, and there's a 2 that I can pull out from all parts by being in C. So I'm going to put a 2 out here. I'm left with a p squared plus 2 divided by 2 is a 1, so we just have p right there. And 2 divided by 4 is a 2. So this comes out to be now 2 times p squared plus p minus 2. So now we have an a value of 1, so we have to ask ourselves the question, what multiplies 2 numbers multiplied by our c value with a negative 2, but add to the a 1? What two numbers? What two numbers? Well, the two numbers that multiply to be a negative 2, I'm thinking are a negative 2 and a positive 1, or a negative 1 and a positive 2. But if I'm adding them together to be a positive 1, I'm thinking negative 2 and positive 2 and a negative 1. Flip that around there. Okay, so a positive 2 and a negative 1 together multiply to be negative 2, but add to be a positive 1. Okay, so double check that. Don't really need that plus side, I guess. I can just eliminate that right there. There we go. Okay, it's all good. Erasers for our markers here, my finger. All right, so now there are two numbers there, 2 and negative 1. We can break this apart into 2 parentheses. Maybe that's parentheses. P for both of them. Okay, we'll put the 2 there, so p plus 2 and p minus 1. And there we have it. Our final factor and answer of 2 times p plus 2 times p minus 1. 4b squared minus 4b minus 8. Well, I like it better when our a value is 1. Currently our a value is 4. But I believe I can pull out a 4 from all parts by b and a c. So I'm going to try that. Put 4 out here. 4 goes into 4b squared 4 times, so we put 1 right there. Then, or 1 time, sorry. Then we pull out a 4 from 4v, and we have a 1, so we have a subtractive v right there. And then 4 goes in 8 2 times, so we have a 2 right there. Okay, we can see that if we multiply the 4 back into all parts, we would get our original expression. So now our a value is 1, we can ask ourselves this lovely question. What two numbers multiply to be negative 2, but add to be a negative 1? Tricky, 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 tricky. Well, these two numbers would come out to be negative 2 and a positive 1. Negative 2 times positive 1 is a negative 2, and negative 2 plus a positive 1 is a negative 1. So now I can break this apart into my 2 parentheses with a v starting each one off. We have 4 times v minus a 2, right there, minus 2, put the minus 2 in there, and times v plus a 1. And there we have our final answer, 4 times v minus 2 times v plus 1. X squared minus 15x plus 50. So I have an a value of 1, which is great. So now I can ask myself this question. What two numbers multiply to be a 50, but add to be a negative 15? Okay. Since they multiply to be a 50 and add to be a negative, multiply to be positive, add to be negative, both numbers are going to have to be negative. So now I'm trying to think, what two numbers multiply to be 50 that might be like near 15? Well, 50, I instantly always think, that's just how my brain works, I guess, 5 times 10. And luckily I know 5 plus 10 is 15. So how can we make it so it works out? Well, a negative 5 and a negative 10. That's a 5 with a big Frankenstein head. Okay? So we have negative 5 and negative 10. These two numbers will multiply to be a positive 50. When I add them, I get a negative 15. So I can break this apart like I always do, with an x in the front of our beginning of each parentheses. And then I plug in the two numbers we found, x minus 5 and x minus 10. And there we have it. Our final answer here that's factored is x minus 5 times x minus 10. B squared minus 7b plus 10. All right. Well, since we have an a value of a 1 right there, I can ask myself this question. What two numbers multiply to be our c, which is 10, but add to be our b, which is negative 7? What two numbers there? Well, both are going to have to be negative because we have two, they're multiplying to be positive, but add to be negative, right? So those two numbers I'm thinking are negative 2 and negative 5. Negative 2 times negative 5 is a positive 10, but negative 2 times a negative, adding in that plus a negative 5 is a negative 7. So break this apart like I always do. V out in the beginning, okay? Then I subtract the 2, right? Or put a minus 2 right there, minus 2, and then minus 5. And there we have it. Our final answer here is just v minus 2 times v minus 5. P squared plus 3p minus 18. Okay, Well, since we have an a value of 1, this becomes fairly easy now. We ask ourselves this question: what multiplies by our c value, which is negative 18, but add to be our b value, which is 3. So when I think about negative 18 and 3, I'm thinking maybe 6 and 3, right? 6 times 3 is 18. Well, can I combine them in any way? 1 has to be negative to be a positive 3 when I add them together. And that's going to be a positive 6 and a negative 3. 6 times a negative 3 is a negative 18, but 6 plus a negative 3 is a positive 3. So now I can break this apart into my two parentheses, p, beginning each one out there. And then we just put the two numbers that are next to them, positive 6 and a negative 3 or minus 3. And there we have it. Our final answer in factored form is p plus 6 times p minus 3. 6v squared plus 66. Too many 6's. V plus, here they keep coming, 60. Okay. Well, first things first. I see there's a 6 in all parts. Okay. Or 6 goes into all parts. So I can pull out a 6 from all parts because I want to have an a value that's 1, which I do now. So 6, when I pull out from 6v squared, gives me a 1 out front there. 6 goes into 66 11 times, and 6 goes into 60 10 times. Okay. Now not so many 6's, but I have it in a form where our a value is 1. So now I can ask the question: what two numbers multiply to b, our c, which is 10, and as b, which is 11. Okay. Well, those two numbers, right, are just 10 and 1. 10 times 1 is 10, and 10 plus 1 is 11. Okay. Be careful. Sometimes it's a little tricky when it's like that. But anyway, we have them. They're all positive. So we have a 6 out front. We can break this apart into two parentheses here. Okay. That's close enough. I can make it. So we have v plus 10, the first number right there, v plus 1. There we go. Our final answer in factored form is 6 times v plus 10 times v plus 1.
Minute math. When you need help, you use Minute Math. Minute math. When you need help, you use Minute Math. MinuteMathTutor.com.